So we did 78. Okay, 79.
I already did 79.
Okay, what is it?
Is it pyramidal?
Okay, that is correct. Because we know that the structure looks like this. Okay, what about 80?
Linear?
Okay, that is correct because we know that the structure looks like this. Okay, 81.
Is that one hydrogen bonds?
That's right. Yep. So anything that's going to be polar. So for instance, we have nitrogen and that hydrogen.
Mm-hmm.
So if it's a strong polarity, then it's going to form, if you have that hydrogen there, it's going to form hydrogen bonds with the adjacent molecule. So this guy's going to be partially positive. This guy's going to be partially negative. So then this guy's going to orient itself so that the nitrogen
bond there.
Yeah. And so they interact, kind of like a fist bump.
Mm-hmm.
Okay. Okay, so match the chemical name with the correct formula.
So I did this one out already too.
Okay.
For 82, is it A?
Okay.
83, B.
Okay.
Number 84, C.
Okay.
85, D.
Okay.
And 86, E.
Okay. Good job. Okay. Identify the following molecules as polar or nonpolar.
So if we're not going to have the electronegativity form.
A good way of remembering whether it's going to be electronegative or if it's going to be a strong electronegative or not is to take a look at where it's located on the periodic table. So for instance, the halogens are going to be relatively strong electronegative, right?
Mm-hmm.
And then oxygen, which is right next to the halogens, that's going to be strong electronegative. Where sulfur, when you get down to sulfur, when you get into that second row, mm-hmm. second and third rows, those, it becomes weaker in terms of the electronegativity. But we're looking at the molecular polarity, right? Mm-hmm. So we're looking at it as a whole. Mm-hmm. So in this case, carbon tetrachloride.
So carbon, and then we have 4 chlorides.
Okay.
So would it be nonpolar?
It would be nonpolar because they're all pulling evenly, right? Okay, so that would be nonpolar.
Okay.
B.
And then H2O, it would be polar.
That's right.
Carbon dioxide, polar.
Think about how it looks.
Carbon dioxide. See. Yeah, because they're.
Think about it. If you have twins pulling on both sides of you.
Oh, nonpolar?
That's right.
Okay. So Nonpolar. Hydrogen sulfide. I put A, polar.
It's actually B.
It's B.
Yeah, it should be B.
Hydrogen.
The reason why is, well, water is polar, but sulfide is weaker. It has a weaker electronegativity. It's about the same as the hydrogen. It's just a little bit more. So if it is polar, it's very, very weakly polar. So I guess, let's say A. It'll be, in reality, it would be considered non-polar based upon the definition.
Okay.
But I'm betting, let me take a guess. I'm guessing that it says polar here for this. And they're probably just looking at the location. That's 90. Yeah, they call it polar.
Polar.
Okay. What about 91? So you're right.
Hydrogen fluoride, A, polar.
That's correct. And carbon monoxide.
Polar.
That's right.
No?
Yeah, you're right. It's polar. So it'd be a triple bond, right? And then where you have the electron spending more time with the oxygen than the carbon. Okay?
Mm-hmm.
Good job. Okay, 93.
I did this one as well.
Okay. So what did you get?
I got D.
D as in donkey. That is correct. Yep. Yeah, since nobody else bothered to show up, none of them are going to look at the video tonight, so because it won't be up. So.
Oh, okay.
Yeah. So the following reaction takes place. Let me put it like this. Which questions do you have so we don't waste each other's time?
I actually had a question on the following ones, 95.
Okay.
Oxidation reduction.
Okay.
And 96.
So I'm gonna teach you a really quick thing to remember. So if we're adding oxygen to something, it's gonna be oxidation, right? And so that means that something else has to be reduced in that case.
So if we're adding oxygen.
Yes, so if you just get oxygen gas added to something, that's considered to be oxidation. Okay, so that means that the other element is gonna end up being reduced.
And when you add oxygen, you're losing electrons.
That's right, loss of electrons, right? Because oxygen starts off at 0, the element starts off. Anytime that you have an element, whether it's diatomic or monatomic, it always starts off at 0 as its oxidation number, and then we get the charge that it would have. So oxygen always has a -2 charge.
Mm-hmm.
So that means that nitrogen here has to have a +2 charge, right? Mm-hmm. And if you're going from 0 to +2, is that loss of electron or is that gain of electron?
0 to +2,
mm-hmm.
That's gaining.
Okay, so 0 to +2 is gaining electrons?
0, losing, because it's the opposite.
That's right. So loss of electrons is oxidation. I use Leo to remind me. And then gain of electron is reduction.
And it's GER.
Yep. So in this case, nitrogen is being oxidized. Oxygen is being added onto it. and then the oxygen is being reduced.
So pretty much when oxidation reduction reaction, we look at the charges.
Yes, you would look at charges if there's charges associated with it, yes.
From the reactants and the products.
That's right, and see which way it's going. Like this is going from 0 to a +2, and this guy's going from 0 to a -2.
Okay. So would the answer be C, since you're working on that? Or
that is C, that's right. Where the other ones, if we take a look, these are double replacement reactions. Anytime that you have a double replacement reaction, it's not going to be an oxidation reduction reaction.
Okay.
Okay, so that's another thing to remember. Okay. Okay, so then the next one, if we take a look at it, aluminum has, when it's normal, when it's an element, it has a 0 charge associated with it. But when it forms an ion, then it forms a what charge?
I'm sorry, aluminum?
Aluminum.
So we're looking at aluminum here. The charge is, are we looking at this one or this aluminum?
You have to look at it both. So initially, it's a metal, right? It has no charge. When it's an element, it's no charge associated with it, right? But when it's an ionic compound, what is the charge on aluminum?
3 negative, positive, sorry, 3 positive.
Okay, so we're going to put 3+ on top for aluminum. Okay, bromine. When bromine is an element, when it's diatomic element, it has a 0 charge associated with it. But when it forms an ion, it has a what charge associated with it?
The same as aluminum?
Well, we have 3 of them. Each bromine has what charge associated with it?
0. It has a 1.
Positive 1 or negative 1?
Negative.
Negative 1. Okay, so each bromine has a -1 charge. Okay, so if I'm going from 0 to a -1, is that gaining electrons or is that losing electrons?
Gaining.
Okay, so then that's reduction, right? Okay, so we know that the bromine is being reduced. Okay, so then that means we can get rid of B, we can get rid of C, we can get rid of, okay, we can get rid of B, C. Technically, you can get rid of D and E. Okay, so now the aluminum is going from 0 to a +3. So if it's going from 0 to a +3, are we losing electrons or are we gaining electrons?
Losing.
We're losing. So that's oxidation.
Okay.
So the correct answer is
A. Okay.
Okay, so now the next question. Which of the following describes the oxidation reaction?
So when it's oxidized, you lose electrons.
Okay, so we know that it's either A, B, or C. So we can get rid of D and E. Okay, so what else?
Loss of electrons or loss of oxygen. Loss of electrons or gain of oxygen. Loss of electrons or gain of hydrogen.
So we know, like I said, we've gotten rid of that one, so we're not going to give it any.
Oh, C, yeah.
So what about C? You said C is no good?
No.
Okay.
Would it be loss of oxygen?
Loss of oxygen. Okay.
No.
Here, when we looked at the reaction up here, were we losing an oxygen? Was oxygen coming out or was oxygen being gained?
Oh, gain.
Okay. So then the correct answer is
B.
okay.
Um, 98, I did it. 99. 100, I did it. 101, 102, 103, 104, 105, 106, 107, 108. A reaction that releases energy is exothermic. What about 110?
110. Okay.
So I know that letter A.
Letter A.
Yeah, that one. I know that this is the reactants and then this is a product.
Okay, good.
But would I get
confused? Let's reactants. So then that would be letter A. Okay. And then you said, would it be D? Is your products? Okay. B is the activation energy. So that's the energy that we need to get up to have the reaction occur.
B.
So B. So B, region B.
Is with B?
Yep, is B. Yep.
Okay.
And then region C that's going to be our heat of the reaction. So that's where you're going from your products to your reactant, and you're taking the difference of that energy. So and that's C.
Okay. Wait.
I'm going to change some of those colors so they're not all the same.
So the heat of reaction, reactants is A, and products is D. B is A.
And you will have one ideal gas law question. So PV equals nRT.
Yeah.
So just remember that. Right?
Yeah.
PV equals nRT.
Pressure, volume, number of moles.
Yeah. And R is the ideal gas constant. Yeah.
And temperature.
Yeah. And temperature always has to be in Kelvin.
Yes.
Yeah.
And the constant, is it 0.0821?
That's correct.
Okay.
Okay. So did you get number 14 and 15?
Wait, I didn't get 112 and 111. 111 is region B. That's the
activation energy.
Oh, B and C. Okay, got it.
Okay.
So
and C is A. Region C is A. The heat of activation, or the heat of the reaction, or enthalpy of the reaction.
Okay.
Okay.
Mm-hmm.
Let's see.
Got it. No, I did not get 114.
Let's talk about it. Okay. So, let's see. Okay, so if energy is being released, then we're going to have less energy in our system, right? So if we take a look at our diagram, this guy is going from a higher energy to a lower energy. Mm-hmm. So that would be an example of either exothermic or endothermic. So we're going from a higher energy to a lower energy. What do you think that's going to be an example of?
From a higher energy to a lower energy?
Yep.
Would that be exo?
That's right, because the only way that we can drop down in energy is if we're losing some of it. It's being released. So that's right. So that would be 115. So by default, the second image, where we're going from a lower energy to a higher energy, so that basically means that we have to add to it. So that would be endothermic, right?
Mm-hmm. Okay, got it. So it's exothermic because the energy is higher.
That's right. So the energy at the end of the reaction is higher.
We're releasing that.
Exactly. That's endothermic, right?
Mm-hmm.
Exothermic is because we're doing this, right? We're going down to a lower energy, right?
Okay.
We're starting here, we're going down to here.
And is that the energy? Is that, so A is exothermic, A is, 15 is A. So is that because we're adding heat to it?
No, we're losing heat, right? Exothermic means that heat is being released, right?
Yes.
So if you're adding heat to it, that means that things are going to go up, right, in energy. So, because remember, energy is always conserved. So if we're losing heat, that means that, so you're releasing some of it, right? So that means that this guy has to drop to account for the heat that's being released, right? Okay. Where this one here, we have to go up because we're adding energy to it, right? So if you add energy plus energy, you're not going to get the same value in terms of your reaction. It's going to cause that reaction to go up to a higher energy level.
Okay. Will there be questions on gases?
There, I told you there's one question on gas. So you need to use the PV equals nRT.
Okay. And then 116 I did, which is C.
Okay. That is correct.
A solution is prepared by dissolving 2 grams of in 100 in solution H2O is a solvent.
That is correct.
Because the solvent is the fluid, the liquid.
Yep.
And the solute is the solid you put in it.
That's right.
Okay. I don't know 18. Are we going to have something like that?
So yes, we will. So oil doesn't dissolve in water because oil is hydrocarbons, right? Mm-hmm. So if we remember, hydrocarbons just has hydrogen and carbon. So what do we know about that? Is it going to be polar or non-polar?
Oh, well, non-polar?
It's going to be non-polar. That's correct. So, and we know that water is polar. So water and oil don't interact with each other because one is polar and one is non-polar. Water likes stuff that's polar. Oil only likes stuff that's non-polar.
So if it's non-polar and non-polar, it dissolves.
Yes, they'll dissolve in each other. Yeah. If it's polar and polar, it'll dissolve. If it's polar and non-polar, it won't dissolve. You'll always get the separation.
Okay. Got it. I got 19, D.
Okay.
I had a question on 120.
Okay. It says, which of the following compounds will not be soluble in water? So in other words, which one won't break down in water?
Yeah, which one won't dissolve?
Okay. So yeah, which one won't dissolve? So remember, we kind of talked about this. We know that group 1 metals, anything with group 1 metals is going to always dissolve, right? Mm-hmm. So are any of these group 1 metals?
The first one is, the second one is.
The second one is, B is?
Oh, no, no. So the
Okay.
only one that's not is phosphorus. Oh, no, that's lead.
Yes, lead.
Lead,
Okay. So by default,
that one.
that's the only one that's not going to, right?
Oh, okay.
Yeah.
So
Although we do have magnesium, but magnesium does dissolve in chloride. I mean, when we put magnesium chloride in water, it breaks down.
So anything in group 1 and 2?
Group 1 and 2, well, mainly group 1 will always be soluble. So anything with group 1 is going to end up being soluble. Okay. If it has chlorine, right? Anything with chlorine is going to be soluble.
Okay.
Right?
Okay.
Except for transitional metals, certain transitional metals like silver and cadmium.
Okay. So group 1 metals are always, okay. 121, a hydrogen bond is so we just went over this, right?
Yep. Hydrogen bond is
a covalent bond between H and O, an ionic bond between H and another atom. Is a bond that is stronger than a covalent bond, the polar OH bond in water. So it's, would it be, I don't know.
It was my example.
I want to say A.
It is A. Yes.
Okay.
Yes. Because it's between two molecules. Actually, in most cases, it's between two molecules. Sometimes you could have it interacting with the same molecule if the molecule is long.
Okay. Okay, this is where I start getting a little with the percentages.
A little squishy.
Yeah.
Okay. So when we talk about percentages are, regardless of how you look at it, it's always going to be the same. It's going to be the part over the whole times 100. Okay. So in this case, we have.
Sorry, this is for when it comes to percentage?
Yes. So anytime we're talking about mass percent or percent volume or percent, okay, it's always going to be the part over the whole. So in this case, what I mean by the part, it's going to be our solute, what's going to be dissolved in our solution. So our part is going to be our sodium chloride. So we're going to have 50 grams of NaCl over our whole is everything that's in that solution, right? So that's going to be what's in the solution.
50 grams and 150 grams of water.
Okay. And then multiply that times 100.
25?
Yep.
Okay. So whenever we're talking about mass, like a percent or percent volume, we'll use the part, which is the solution.
That's right. No, the part is not the solution. The part is what it is, the solute, right? So the part is just a specific part. So it could be the water or it could be the solute, right? Okay. The whole is everything else, all of it together.
Okay.
Okay. Okay. So our next question, it says, rubbing alcohol is 70% isopropyl alcohol by volume. How many milliliters of isopropanol is in a pint of, in 1 pint container? So if all together we have 473 milliliters, and we know that we have 70% of it is going to be isopropanol, then we just need to multiply this by 0.7. And then that's going to tell me how much alcohol I have in my solution.
$675. Wait, did I do that right? 473 times 0.70. Oh, 331.
So we have 2 sig figs, so 330.
Okay. Okay.
Okay. So it says, what concentration in mass per volume percent of a solution prepared from 100.0 or 100, I'm sorry, not 100, 50 grams sodium chloride and 2.5 liters of water?
So we would.
So usually when we go mass, so that's M stands for mass, V stands for volume, right?
So 50 divided by 2.5?
But it wouldn't be 50 divided by 2.5 because we normally would put it in milliliters, right? This number would normally be in milliliters. So we have to change that to milliliters.
Oh, okay.
Right? So then that would be 2,500 milliliters. And then we multiply that by 100.
$0.02.
Did you multiply by 100?
Oh.
Because you want it in percent. So
that's right. So 2?
Yep.
That's right.
Okay. So how many grams of glucose are needed to prepare 400 milliliters of a 0.2% mass per volume glucose solution?
So we need to, the 2.0, we need to change that to a decimal.
Okay, we need to change that to a decimal.
So we divide by 100.
Divided by 100, okay.
Which is
0.02.
And now we use that M over V.
Okay. So then we multiply it by the volume, right? And we know that this is grams per milliliter. So milliliters are going to cancel out, and then we're going to be left with just grams.
So 8.
Yep, that is correct.
Okay. The patient needs to receive 85 grams of glucose every 12 hours. What volume of a 5.0% glucose solution needs to be administered to the patient each 12 hours? I tried to do that one, but I didn't get it.
So now that you know what you know, how would you set it up?
I would do, so we need to get to milliliters. Okay. So first I would convert the percentage.
Okay. The decimal.
So 0.05.
Yep.
And from gram, 85 grams, I need to convert it to milliliters.
Okay, so now remember, you've changed this. Now, again, the units for this is going to be grams per milliliter, right? So that's going to be the units because it's mass volume, right?
Oh,
okay. So then if I have grams, how can I use this conversion that you just made for me?
85 grams, convert, and then 1 gram on the bottom.
Would it be 1 gram? Look what's...
Oh, 0.05.
Okay.
Grams per 1 milliliter.
That's right. Are you working in the lab, Robin?
Sorry, say that again?
I said, are you working in the lab?
No. Sorry.
Oh, hi, Robin.
Hi.
So what did we get? Lucy, are you there or did you freeze on me?
So 1,700 milliliters?
Okay.
Oh, sorry. Did you say on
A?
or in the lab?
Hey. I said, are you working in the lab? Because your background is in the lab, as a lab, it looks like.
Oh, no. I just blurred it because my room's a mess.
Oh, okay. So A is correct. Okay.
Mm-hmm.
Does that make sense, Lucy?
Yes. So we would do the same pretty much for 127.
That's correct.
And then 128. We would, because it's asking for molarity. So first we get to moles.
That's right.
And then we do the moles divided by liters.
That's correct.
Okay, I know that one.
So 17 divided by 17, isn't it?
Yeah.
So then that's
2. The answer is 2.
Yep. So it'd be B, right?
Hmm. What about 129?
Okay. It says, when 200 mils of water is added to 100 milliliters of a 12% KCl solution, the final concentration of KCl is, okay, so let me show you a little secret. So you would go C1 times V1 equals C2 times V2. And we kind of talked about this in one of our labs, where C1 is the concentration of one of them, and that would be the volume that pertains to that. And C2 would be the concentration at a different volume, too. Okay? So you just plug it into this equation. So when we add 200 mils of water, right? So altogether we have 300 mils, right? So what we would do is we'd say our V2 equals a total of 300 mils. C1 equals 100 mils, equals 12%. That would be our concentration. V1 equals 100 mils. And then just so we remember, our V2 was the 200 plus the 100 that we already have.
And we're trying to get C2.
That's right. We're calculating what C2 is. Okay, so if we do our math, we solve for C2. So we get C1 V1 over V2. So we'll get C1 is 12. V1 is 100 over 300. Not be lazy.
Four.
Okay, so it'll be 4%.
Okay.
Okay.
Mm-hmm. And then 130, how many moles of CaCl2 are in 250 milliliters of a 3.0 m of CaCl2 solution?
So how would I do that? So I know that this molarity means what? What does molarity mean? That M.
The equation for it?
Yeah, how would you calculate it?
Moles over liters.
Okay. So it actually means moles over liters, right? So we have 3 moles. We look at it. It's 3.0 moles over 1 liter. That's what it means, right? So if I have 250, my starting out is 250 milliliters, what do I need to do to those milliliters?
Turn it into liters.
I need to change it to liters. And how is
that? 250 milliliters, and then 1,000 milliliters in 1 liter.
Okay, 1,000 milliliters. One liter. Milliliters cancel out. So I believe it's D as a donkey.
Okay.
Check my math.
Yeah, that's what I got.
Okay.
And then 131.
Okay. It says, what volume of a 1.5 molar potassium hydroxide solution is needed to provide 3.0 moles of potassium hydroxide?
So it's asking for volume.
Oh, would it be 2 liters?
Okay. So we would start off with what's given. This is going to be used as our conversion. So we have 3.0 moles. We know that this means 1.5 moles over 1 liter. Then we flip that around, right? So then we end up with 2.0 liters.
Oh.
That's correct, Robin. Okay. So that's how you're going to use your concentration.
Okay. What's a catalyst?
It's a chemical compound that reduces the amount of energy required for a reaction. At least that's how I understand it.
Can you repeat that?
It's a chemical compound that reduces the amount of energy required for the reaction to start. So it basically speeds it up. And it
so would it be C?
Which one are we looking at?
134.
You moved to 134. Yeah. So a catalyst just basically speeds up the reaction. Yes.
Okay.
So if a catalyst speeds up a reaction, then it's going to be
substance that speeds up the reaction without being consumed in the reaction, yeah. Because it's not part of the reaction.
That's right. Okay, so the activation energy of chemical reaction, the activation energy of a chemical reaction is the energy that A, must be removed from the mixture, B, must be released from the mixture, C, initiates the reaction, D, activates the catalyst, E, the difference between the energies of the starting materials and the products.
I would say C, initiates the reaction.
That is correct.
You have to get over the hump.
You got to get over the hump. That is correct. In a catalyzed chemical reaction, one function of the catalyst is to A, increase the number of successful reaction collisions, B, decrease the concentration of the reactants, C, change the equilibrium concentrations of the products and the reactants, D, increase the energy giving off during the reaction, E, increase the temperature at which the reaction is carried out.
I would say, I'm not sure about this, but I would say A, because concentration of reactants, like for the reaction to occur, well, I mean, I suppose you need like a certain amount of concentration but decreasing the concentration would lessen the likelihood of the reaction occurring. And then not every reaction is going to be an equilibrium reaction, and increases the energy is the antithesis of a catalyst. And there's no way that a catalyst can increase the temperature. So I'm thinking like for a reaction to occur, it needs to have enough kinetic energy, and it needs to bump into each other at the right angles.
Yep. So correct answer is A. Yes. Okay, indicate the effect on each, indicate the effect on each change upon the rate of the reaction. A, to increase, or B, decrease. Adding the catalyst.
Increase.
That is correct. Removing some of the reactants.
Decrease.
Okay. Temperature doubled.
Increase.
That's right. Concentration of the reactants decreased.
Decrease.
More collisions between the molecules occurring.
Increase.
It's so funny. It's like you guys are alternating. Did you plan that?
Yeah.
Got to take turns, you know.
Yeah.
Okay. Acid and bases. Okay. According to Arrhenius concept, if sodium hydroxide is dissolved in water, it would act as
a base.
A base, B, an acid, C, a source of the hydronium ion, D, a source of the H- ion, E, a proton donor.
A base?
A base. That is correct. According to the Arrhenius concept, if HNO3 were dissolved in water, it would act as A base, B, an acid, C, a source of the hydroxide ion, D, a source of the H- ion, E, a proton acceptor.
An acid.
Okay. An acid. That's correct. Okay. 144. The name given to an aqueous solution, HBr, is hydrogen bromide, B, hydrobromic acid, C, bromic acid, D, bromous acid, E, hypobromous acid.
B?
Did you say B as in boy, or did you say D as in dog?
B as in boy.
B as in boy is correct.
And that's because it has the one hydrogen, right?
No, it's because it has hydrogen and it doesn't have any oxygens.
Oh, I see. Okay.
The given name to an aqueous solution of HNO3 is A, nitric acid, B, nitrous acid, C, hydrogen nitrate, D, hydrogen nitrogen acid, E, hyponitric acid.
So NO3 is nitrate, and then it becomes nitric.
That is correct. So you would say A then, right?
Yeah.
Okay. Conjugate base. So the conjugate base of HClO3 is A, HClO2, ClO3 minus, Cl parentheses OH parentheses 2, ClO3, HClO. It's conjugate of anything is on the other side of the reaction. So if we have HClO3 as an acid, what happens to that acid?
It turns into H2O.
An acid does by itself?
Oh, no. So it disassociates into like the H plus ions, right?
Yep. So we get an H plus and we'll get
the chloride or the chlorine oxide.
the chlorate ion, right?
Chlorate, okay.
Okay. Now don't start making stuff up. That's chlorate, right?
Yeah.
Okay. And this is the H plus ion, right? Okay. So then this guy is considered the conjugate acid, right? Because it has that H plus. And then this guy is considered the conjugate base. This is the conjugate base.
Oh, okay.
Okay, so the conjugate acid of HSO4 minus is HSO.
Wait, what was 46?
Oh,
It would be B, yeah.
because it's the conjugate base. That's what we're looking for.
Oh, okay, okay, got it, got it. So HSO4 negative yield to H positive AQ. And SO4 has a -2 charge, right?
SO4 has a -2 charge altogether. Yes.
Yes.
So it says the conjugate acid of HSO4 minus is SO4 2 minus, HSO4, H2SO4, H2SO4 minus, HSO3. Now, again, the acid is going to be getting an extra hydrogen in this case. So the conjugate acid is going to get that extra hydrogen. So what would it be?
Would it be H2SO4?
Yeah.
Negative?
No, not negative, because you're adding the hydrogen. That hydrogen is going to be a plus, right? It's going to balance out that negative.
Okay, got it.
So when it's a conjugate base, you just disassociate it, and then the conjugate acid, you just add another
H plus to it.
H plus. Okay.
Yeah.
Man.
So it's sort of that. There's little fine tunes to it, this question, but for that question, that's what you're going to do.
Okay.
Okay, which of the following statements correctly describes the hydronium hydroxide balance in a given solution? In acids, OH minus is greater than H3O plus. In bases, OH minus equals H3O plus. In neutral solution, H3O plus equals H2O. D, in bases, OH minus is greater than H3O plus. In bases, OH minus is less than H3O plus.
It would be D.
D as in donkey is correct.
Mm-hmm.
Because we know if it was an acid, we're going to have more H3O plus.
Mm-hmm.
Mm-hmm.
And if it was neutral, the H3O plus is going to equal OH minus. Okay. What is H3O plus in a solution with OH minus equal to 1 times 10 to the minus 12 mole?
Okay. So would you take the log,
Mm-hmm.
the
Okay.
negative log,
Okay.
and then that would give you the POH.
Okay, so then we'd get, that's 12, right? It will be 12. Would be my POH.
And then there would be
14.
pH plus POH equals
That's 14
minus 12.
12, and that's going to equal my pH.
Mm-hmm.
And then, which gives you 2. And then your 2 becomes the negative exponent. So it gives you E as an eagle.
Okay.
So the log, we just put 10 to the negative 12 log.
Yeah.
Oh,
Yeah.
you know what? I think we have to put a different, I think in my calculator, I have to put it different.
You have to do yours differently, yeah. Because I remember we were doing this the last time and we kept having troubles.
I have to use 1.
Yep.
Times?
No, it'll be 1 EE.
Oh yeah, I had the same issue.
And then the, no.
Yeah.
Okay. I have to remember that.
Or you could use maybe 10 to the
Because if I do 10 to the negative 12 log, it gives me negative 11.
Yeah, because you're multiplying it by, because the way you put it in, you're multiplying that by 10. So that's the same thing that Robin had done the last time.
Yeah.
So that's the reason why you have to put 1. Yeah. Okay, it says, what is the concentration in a solution that has 10 to the
Negative
1 times 10 to the minus 6 concentration of the hydronium ion?
Oh, okay. So you take the, yeah.
Yeah, so it's the same problem, but done the opposite way, right?
Is it B?
Nope.
Or C?
Let's see, because it should add up to 14, right? So this guy is minus 6. This guy is minus 8. So it should always add up to 10 to the minus 14 when they're multiplied to each other, right?
Okay.
Well, that's a quick way of remembering.
E, negative 6.
So here, this guy is 10 to the minus 4. So then the concentration for the OH should be 10 to the minus 10, right? Which means that its pH is going to be
4.
Its pH is going to be 4?
No, hold on, I'm confused. So what is the pH of a solution with hydroxide with 1 to the, so you take the log of that, you get 4 for the POH, and then you do 14 minus 4, so it'd be A as in alligator.
That is correct. A is an alligator. Okay. So I'm actually going to stop here because I have to go and give a review for my other class too. So was that good? Are you guys good?
Mm-hmm.
And any questions that you guys may have on any of the things that we haven't covered, right? Before, I'll be there an hour before your exam. So you guys will be, well,